OK. Back again. What is this? Stranger Things. What season? What episode? Well, OK. This talk is going to be all about GIF from Stranger Things. I'm not going to talk about Angular or JavaScript. I'm just going to show GIFs. No, I'm joking. 100% Lighthouse score. OK, everyone wants like 100% score. This is kind of like the dream goal. You're like performance, progressive web app, accessibility, best practices, CEO. You just have it all. You show it to your boss, and your boss has said, yes, take this, take more money, and just work for me for other 20 years. That's actually not the case, but the truth is, when I started working at Coinbase, I was like, OK, let's see what's the score of Coinbase.com. That was the score. We had the performance 4, progressive web app was not a thing, and some best practices. First contentful paint was 8 seconds. Is actually, if you see, it's in millisecond because this screenshot was from over a year ago. So that was not the latest version of Lighthouse. And time to interactive was 20. So 8.5 and 20 seconds. Well, this is, when you see this kind of thing, the first thing you thought is like, we have a lot of space to improve, and there is a lot of cool things we can work on. And that's what we did. We were going to leveling up. We work on fixing some dependency upgrades. We went from Webpack 3 to version 4. We did some. We fixed some tree shaking. It's interesting the part about tree shaking, how you think it's working, but then is not actually doing its max. We also fixed like the preloading, some font animation, and then after all this kind of like small optimization, after 6 months of work, we got a little bit better. We went, first contentful paint was 1.7 seconds, time to interactive was 8.5, and the performance score went from 4 to 48. And that's good because that means we have not only like give a better experience to our user, but also like we still have a lot of space to do even better. But let's go one step back. What kind of performance we're trying to improve? Why they matter? And why is we're so obsessed with, I don't know, Chrome DevTools, Lighthouse? So what we've been told is there are 2 types of environment. There is performance in the lab and performance in the real world. Performance in the lab is the one that we are used to. So you have like a controller environment, your machine or your data center, something that you know the CPU and the network, what's the state. And that you can use Lighthouse or Chrome DevTools to emulate maybe a 3G connection, a 2G, and that's how you kind of like emulate and get some synthetic data. But that's not the whole truth. We want to understand if all our users, if you're delivering just a website for your town or your country, it's fine. But if you're developing a website, a web application that actually is used like in many countries, in different continents, like Coinbase, we try to give it the best experience as much as we can, not only in the United States, but also in Italy, in Asia, in South America. And that's where we want to also do not only like performance in lab, but also performance in the real world. So understand from for the user, how is your first contentful paint? A nice way to think about it is a unit test versus integration test or functional test. With unit tests, you kind of have like a controlled environment where you have your input and you try to check your output. So you do like Lighthouse and Chrome DevTools. Performance in the real world, or also called like RUMs, real user measurements, that is a little bit like integration tests. You may be kind of like testing with a staging environment, so something could be unpredictable, and that's good. That means you won't understand when it's unpredictable, so you can fix it. Well, again, I'm Leonardo Zizzamia, originally from Taranto, and now I live in San Francisco, and I've been working for Coinbase for the last year. And we're going to talk about keeping 100% Lighthouse code around the world. Oh, and if you want to find me, just my last name. It's pretty rare. To be fair, there are only 50 families, all of them are in Lucania. If you don't know where Lucania is, it's just like a part in South Italy. OK, performance timeline. We have the first contentful pane, the time to interactive, and the first input delay. So we're going to focus right now to first contentful pane and first input delay. And the reason is time to interactive. It's really hard to calculate everywhere in the world. We tried. It was a little bit unreliable. It was also kind of like taking time to get all the resources. It just didn't fit well. Because remember, every time you want to measure something, you should not slow down your project. It should cost just maybe 1 millisecond or even less. Well, what we have? If we can't use Lighthouse, if we can't use Chrome DevTools, we need to use the Web Performance APIs. Some of those you probably already know. There is like performance.now. It's a very high-resolution time where you can go even better than millisecond to understand how long it takes to do a specific thing in the website. But also, we have the performance object that is enriched with things like performance.mark, performance.measure. But one in particular API that we're going to dive in this talk is performance observer, which is interesting because it's been in a draft for the last few years, and slowly it's been adopted more and more from different browsers. So how does it work? Performance Observer is really simple. You just take like the object, you make an instance, you define, you'd say, please observe the entry type. There are different entry types. There is paint, resources, and the one that we're looking now, it's paint, because when you ask to use the entry type paint, you're going to get back the result for the first paint, a first contentful paint. The entry type, the performance entry object that you're going to get back, it simply looks like this. It says, this is the first paint, this is the first contentful paint, and this is the start time, the measurement that you need to know. If you see, there is a lot of like decimals. This is because it's not using date now. We are using internally is using performance.now, which is more precise. Performance Observer is so simple that you just need this line of code. You just do an instance, you ask what you want, you create a background. The reason you want a background is because first paint, the first contentful paint are slightly different. And then the first paint, it's all about you type your website, it opens on the browser, it goes from a white screen to maybe yellow or gray. And the moment you change the background, that is the first paint. The first contentful paint, it's when any content, there can be a text, there can be a canvas, there can be anything that is being rendered for the first time. That is the contentful paint. And now we are kind of like fake it. We're faking with like with a set timeout. We say, please wait 600 milliseconds and create an element and just attach that content to the body after that. So there are two things you need to notice. The first is we're first changing the background, and then we add in the text. On the bottom, on the console, you first see the first console where there is the first paint that is like 900 milliseconds. And then a few milliseconds later, there is the first contentful paint, which is 1.5 seconds. Not too hard, but there is a trick. Performance Observer isn't perfect yet. It's under draft. They're still working on it. There are some bug fixes. With Firefox, it didn't work till the version 63, and there is a lot of false negative result. Like when you ask the Performance Observer to just like measure something, and you ask it, and you change tab, and you go back, it doesn't understand that you changed tab. It's just going to like, if you're, for example, like you open your page, and then you go to Facebook, and after 3 hours, you go back to your website, the first contentful paint is going to be 3 hours. Which is not exactly the truth. That's the thing. When there is all this kind of like experimental API, if vanilla isn't enough, we should add some sugar code. And that's what I did. I started adding some sugar code for myself, and eventually I just like, you know what? I'm just going to put it on GitHub. In case someone finds a bug, they're going to help me. But I need a name. OK, performance. Performance, I keep thinking, and then there was like perf matters, it's a big hashtag famous on Twitter, and then I just come out with perfume. It's very stressful, actually, change the logo every time I increase the version. So now it's 2.1. And it's an open source. You can find it on GitHub. It's very interesting how easy it is sometimes when you have an open source project and people just find bugs for you. Like, it's fun, like I was at Coinbase, and then I discovered that something was causing like an error in Chrome, like 56, like an older version from like 2.5 years ago. And then I was like, oh, OK, let's go to GitHub, let me fix it. And as soon as I go to GitHub, there was a pull request of someone from somewhere else that just opened it and fixed it. I was like, yes, open source works. Besides the time they actually ask to fix something and I have to do it, that is cool, especially if you do it on a weekend. Let's see, I want to show you something in particular. So this is the website, which is pretty interactive, so you can play with it. It's quite fun. And if we go down, a little bit down, there is a nice explanation on how to use it with Angular. It's pretty straightforward. It just kind of like it's easier to just have a service that you can just reuse everywhere, just in case you need the performance instance to just collect some particular data. But also the best part is the decorator, perfume after viewing it. And that's because we don't want only calculate the performance at the beginning, but we also want to calculate sometime, not all the time. So if you have like a page component and you want to just see how long it takes, maybe, and that's very interesting about the component part because we go back to the integration test. The component part is just going to say how long it takes from the initiation to the first view init to the after view init to just say, OK, this component took 400 milliseconds. It's not 400 milliseconds of like CPU time that you were doing some crazy JavaScript. It was possibly just like you were doing an API call, and you had a promise, and you were just kind of like waiting a bunch of stuff to kind of like return before showing the whole page. And that's interesting because that you can like, as an integration test, you can figure out if you even have some API that just not on your localhost, but in production, that's just a little bit too slow. One thing, be working on the new version 3, because recently the Performance Observer, finally they start fixing some stuff. And one particular point of Performance Observer is when it doesn't really work with server-side rendering, which is sad. And the reason it's sad is because I use server-side rendering a lot. And every time you instantiate the Performance Observer, it's just going to calculate anything that happened after the instantiation. So if you have a server-side rendering that just does the first contentful pane like this, super fast, it's not going to capture that. But now, recently, like a few weeks ago, we got, let's see if I got a little bit bigger. So I wrote this line actually a couple of weeks ago, which is entry type and buffer2. Buffer2 is a flag. It's a flag that is already automatic set with Perfume. If you're using with vanilla, you should just use it by yourself. And the best part is it just retrieve buffer events, subscribe to new events for painting time. So it's a subscription model that it just goes backwards. The browser is going to collect for you already the first contentful paint, even if you don't ask. And what Performance Observer does, it just goes to the memory and says, oh, can you just give me this, please? So that you kind of like keep it for yourself. And that's awesome because that we can have measurements also if you're using server-side rendering, if you're using Google Tag Manager, or if you're just like dropping perfume just later in the loading time, which is actually a good idea. Every time you want to calculate analytics or performance, you don't want to stress the initial loading. You want to do these analytics probably like a few seconds later. OK, let's go back to the original slides. Cool. Okay, so this is our website, perfume.js.com. And using Perfume is pretty straightforward. You drop the library, you do the exact thing, you create an instance, you say that I want the first paint, I want the first contentful paint, and the result is the same. When change the color and the content, you're just going to see a nice login. It's quite flexible. You can change what kind of login you want, if you want debugging, if you want to connect to the specific analytics. And to just recap, there is like, you get all the benefit of the performance API with Performance Observer. I'm also adding some other stuff to calculate the time to first byte, mostly because the goal of the library is just like make it easier what is the performance API does. And the reason I want to make it easier is just because I want to spend less time to work on this. So it's cross-browser tested. There are over 20 million people that already use the user that already use the library. There are over 600 stars, and it's been downloaded over 40,000 times around the world, which is great because it give us the opportunity to find bugs really quickly. And it's very flexible because you can use async await and also waste zero time, because every time you actually do an analytics part, it doesn't do when you calculate something, it just waits. I don't know if you ever use the idle until urgent strategy, but beside Perfume, beside Angular, it's just a good strategy to just say, please, when you have to do this analytics, don't do it now, just wait when the browser is idle, when it's not doing anything, and just use that moment. So first paint, the first contentful paint is to see something happening on the browser. First, input delay, it's a nice way that when you're on the page and you click, if you see 3.2 seconds on the screen, so I'm scrolling, nothing is happening, and then as soon as I click, it goes from first input delay from 0 to 3.2. Or in this case, actually 5 seconds. The point is, first input delay is figure out how much junk of memory leaks and just advent listener you have on your website during the loading time. I mean, this website is very simple, so it's not a big deal. But if your website is just creating so much advent listener all at once, most of the time, it could go like 50 seconds or 70 seconds, and that's just time that the user feels like slower. Anything less than 50 seconds is OK. But if you cross the 100 milliseconds and you go to 300 milliseconds, that is actually, it feels janky. It feels slow. You definitely don't want that. Performance.mark, it's really powerful because you can actually say, I want to start measuring from this point and stop in this point, anywhere in the document. So for example, with Angular, you have the perfume service, and you can go from one component to another, and you measure from the component A, you do a lot of things, API calls, some other logic, and then in component B, you're like, OK, now stop it. And then you can, over time, see if its time is getting longer or shorter. In this case, for the Coinbase, I use the performance.mark to check the asset page paint, which is 900 milliseconds. And the reason it's 900 milliseconds is not because the code is complicated. It's just that we're doing a lot of API code that we can still do optimize, and we can do better. Some interesting thing is about Perfume is it's very flexible. You can attach any analytics you want. Google Analytics, Mixpanel, Amplitude, Datadog, whatever you use, doesn't matter. Perfume just gets the data and just give it to you. And you should definitely collect them and see. By the way, all these data are anonymous. You're not collecting data from the user. You're just getting random browser, random user agent. This is the speed that they have. This is a show of Coinbase where the first contentful paint, on average, is between 2 seconds. That goes 2.2. Then we have a spike. We check the commits. It's like, what the heck happened there? And then we revert it. We fix it. And we go back in track. But that's very interesting because sometimes when you merge stuff on production, you think it's going well because you're just testing with your very fancy machine, your nice MacBook, or just like a nice computer. And then when you kind of like test it with the real people, you're like, oh, actually, we slow down the website 30%. And the same you can do with the first input delay, and you can also do with, when I did like the performance.mark, that usually is called a hero paint. The hero paint is not standardized because you decide which one is your hero paint. You decide which one is the paint that you want to measure. And now we're still experimenting in Coinbase, so we took the hero paint of one component, and we're kind of like track it to see how useful it can be for us. A key part for the RAM, real user measurements, is that you can collect all the devices in the world. So that means what we have. OK, it's a little bit bright, but on the bottom, there is a blue line, which is the United States, the one that we saw before. And then we have like Italy, we have Brazil, Australia, and you till going up, which is Nigeria, that is 5.8 seconds. And that's very interesting because you can actually understand, for example, if you have customer, if you're in e-commerce and you have customer from a specific part of the world, this is a good way to make sure that you are giving a similar experience from Italy to this other country. And the same you can do for the mobile. And I also have cool stickers. Yeah, I'm obsessed with stickers. I've been making stickers from as soon as I start making open source project. So after the talk, if you find me, I have stickers with me. And you can just like ask me. I'm going to give you some free one. And that's a wrap. Thank you so much.